Hello and welcome back to Sleepy Science Stories. Tonight we're journeying to a quiet, invisible border, the edge of space. It's closer than you think. Just above the clouds, where blue begins to fade, the air grows thin and the last breath of our world dissolves into silence. If you could rise through that fading light, you'd see the curve of Earth fall gently beneath you, a fragile marble wrapped in silver air. Above nothing but darkness, not emptiness, but depth. A sea without a surface. And so the question comes softly, what lies beyond the edge of space? Does the night end somewhere, a boundary where even starlight stops? Or does it unfold forever, layer after layer, until wonder itself runs out of words? That's where we'll drift tonight. Past the fading air, past the quiet hum of satellites, into the deep, unbounded dark. If you find these calm explorations soothing, a gentle like or soft tap on the subscribe button helps other sleepy minds find their way here too, one quiet soul at a time. So settle in. Let your breath slow to match the Earth's turning, and let your thoughts lift past the clouds, past the blue, toward the endless question waiting at the edge of everything. The question drifts outward, what lies beyond the edge of space, and somewhere in that wondering, it begins to fold back on itself. To ask what lies beyond, we must also ask what came before the stars, before the blackness, before space itself had anywhere to reach. Close your eyes for a moment and imagine nothing. Not an empty room, not a dark void, not the pause between sounds, but nothing. No space, no time, no direction to move or measure. Even the word before doesn't apply because before needs time, and time has not yet begun. From that, nothing, something begins to hum. Not in sound, but in energy, a tremor in the fabric that will one day become space. And in an instant so brief that the word instant fails to describe it, the universe begins. The Big Bang. It is not an explosion in space. It is an expansion of space, a blooming of dimension itself, tiny, hot, and impossibly dense, swelling outward not from a point in emptiness, but everywhere at once. Everywhere that ever will be unfolding in a single silent moment. That was roughly 13.8 billion years ago, though years are meaningless that close to the beginning. In those first fractions of a second, space-time inflates at an unimaginable rate, doubling again and again a cosmic heartbeat that sets the rhythm of existence. The temperature is beyond comprehension, trillions upon trillions of degrees. Matter and energy blur into each other, inseparable wild. As the expansion continues, the universe cools just enough for energy to condense into particles, quarks, electrons, photons, the alphabet of reality beginning to form its first letters. Quarks gather in threes to form protons and neutrons. Protons and neutrons form the nuclei of hydrogen and helium. Simple light, abundant. The first building blocks of everything that will ever exist. And yet the young universe is still dark. There are no stars, no galaxies, no shapes. Only a sea of hot plasma light trapped within matter scattering endlessly, unable to travel freely. If you could have seen it, then it would have glowed with fierce brightness, but no light could escape. The cosmos was luminous and blind all at once. For nearly 400,000 years, the universe expands and cools. Atoms form as electrons find their places around nuclei. Light is finally free to travel, the first photons streaming outward through newborn space. That ancient light still exists, stretched and softened by time into the faint microwave glow we can measure today, the cosmic microwave background. A whisper from the dawn, the oldest light we can see. Billions of years later, we build instruments that can hear that whisper. Radio antennas tuned to the faint hum of the universe's first breath. When scientists map that glow, they see patterns, slight ripples like the texture of a calm sea after wind. Those ripples are the seeds of everything gravity's fingerprints gently tugging matter together into clumps, into clouds, into the structures that will one day form stars and galaxies. But it will take time. Hundreds of millions of years of silence and cooling before the first lights return. This waiting period, this long cosmic exhale, is sometimes called the Dark Age. No stars yet burn. No galaxies have taken shape. Only the slow, invisible work of gravity pulling, collecting, weaving matter into the quiet architecture of possibility. Then, after about 400 million years, hydrogen and helium gather densely enough to ignite, and for the first time since the beginning, darkness ends. A star is born. Imagine it, a sphere of hydrogen collapsing under its own weight until its core grows hot enough for fusion to begin. Nuclei fuse into helium, releasing energy, light, and warmth, and suddenly the universe shines again. These first stars mark the cosmic dawn. Their light is faint to us, stretched by billions of years of expansion, but in their own time, they blaze with unimaginable brilliance. Each star burns for only a short while, a few million years at most, but their light transforms everything. They reionize the fog of gas that filled the universe, making it transparent again. Their radiation clears the mist. Their gravity sculpts space, and their deaths sow the first heavy elements. In their fiery cores, hydrogen becomes helium. Helium becomes carbon, oxygen, and iron, the raw materials of life. When these stars die, they do so violently, exploding in supernovae that scatter their enriched cores into the void. From that stardust, new generations of stars are born, each one carrying a little more complexity than the last. Planets begin to form around them. Moons, oceans, mines. And here, billions of years later, a small species on a pale world looks up and wonders what lies beyond the edge of it all. It's remarkable to think that the question we whisper into the dark tonight began inside that same fire. The carbon in our breath, the iron in our blood, the calcium in our bones, all forged in ancient stars that lived and died before our sun was born. In a way, the Big Bang didn't just create the universe. It created us. Every thought you have, every word spoken, every heartbeat, all trace their origin back to that first pulse of light. The expansion that began then has never stopped. Even now, space continues to stretch. Galaxies drift farther apart. Light from distant stars grows fainter, redder, older. And yet, that motion is gentle, constant, endless. If you could step outside of time and watch the whole history of the cosmos unfold at once, you'd see a kind of breathing, a slow inhale from nothingness into everything. Galaxies blooming like frost across a window, clusters of light threads of darkness, gravity and radiation dancing in perfect balance. It's easy to imagine the Big Bang as a beginning, but maybe it's better to think of it as a transformation, the moment when potential became reality, when the silence found a rhythm and began to sing. And that song continues. Through every star, every atom, every mind that wonders about its own origin. Even now, telescopes orbiting high above Earth listen for the faintest echoes of that birth. They catch photons that have traveled billions of years, tiny messengers from the beginning of time. Each one a note in the symphony of existence. To ask what lies beyond the edge of space is to ask what lies beyond that music, beyond creation itself. But the universe offers no edges, only continuities. What began as expansion still expands. What began as light still shines. And what began as question still echoes softly through human thought. So, as you lie here, maybe half awake, maybe already drifting towards sleep, imagine that first instant of everything. Imagine the universe as a single spark that still burns its light passing through you now, through the walls, through the air, through the very atoms that once belonged to those first stars. Every breath you take carries that story forward. Every glance at the night sky is a reunion with the beginning. And in the quiet between one heartbeat and the next, the cosmos continues endlessly expanding, endlessly becoming, while you rest at its center, listening. The story of the universe continues to unfold slowly, delicately, and with every generation we build new eyes to see further into that unfolding. From the first spark of the Big Bang, the cosmos expands outward, and with it our curiosity. It is no longer enough to simply gaze upward and wonder. Now we reach. We build instruments of glass and gold steel and silence to capture the faintest light that has traveled across time itself. The most powerful of these instruments drifts far beyond our atmosphere, a golden mirror suspended in darkness. It is the James Webb Space Telescope, a time machine made of light. You may remember the day it launched, December 25, 2021, a quiet gift from humanity to itself. While much of the world celebrated on Earth, this telescope began its slow journey outward, carried by a plume of fire rising through the thinning blue. Through cloud, through stratosphere, through the fading breath of the planet, it climbed into silence. For nearly a month it traveled to its home, a place called Lagrange Point 2, or L2, about 1 million miles away. There, Earth and Sun balance their pull so perfectly that Webb can drift in harmony, always facing the deep. One side forever turned toward the stars, the other shielded from the heat of the sun by a silver sail as thin as a whisper. Once there, the telescope unfolded like a flower opening in slow motion. Panels, mirrors, sensors, each piece stretching carefully into position, guided by mathematics, patience, and hope. It was a choreography performed across space, each move practiced for decades, each click of machinery echoing through the silent void. And when at last it opened its eyes, it saw not just stars, but time itself. The James Webb Space Telescope does not see as we do. Our eyes catch visible light, the narrow band of color between red and violet. Webb looks deeper into infrared, the long-stretched waves of light that travel unseen. Infrared light is what happens when the universe grows old, when distance and expansion pull color apart, when ancient galaxies drift so far that their glow becomes a soft, invisible warmth. Through this vision, Webb can see through clouds of cosmic dust into places where stars are born. It can pierce the veils of nebulae, those vast nurseries of gas and shadow, and reveal the cradles of creation within. It can reach back across more than 13.5 billion years, capturing the faintest light from the first galaxies that ever formed. Think about that for a moment. The light Webb detects tonight began its journey before Earth existed, before our sun lit its first flame, before any life had begun to dream of skies. That light traveled across the expanding fabric of the universe for billions upon billions of years, through epochs, through collisions, through eras of darkness and rebirth, until finally it met a golden mirror floating in silence, aimed by human hands. And in that mirror it found its reflection, the first image, the first proof that we could look back to the dawn of everything. When NASA released those images, they were unlike anything we had ever seen. Galaxies upon galaxies, spirals, ellipses, threads, each one a collection of hundreds of billions of stars. Some shone brightly in their prime. Others were faint, stretched by distance, their light ancient and tired. And beyond them, the darkness was not empty. It was alive with color, shape, and time. In those pictures, we saw a truth that humbles and soothes. There is no edge, no wall, no final horizon. Only layers of unfolding light, older and fainter, fading gently into mystery. The James Webb Space Telescope changed what we thought the early universe looked like. We expected chaos galaxies, small, unformed, clumped like scattered dust. Instead, Webb found structure galaxies that were already large, organized, bright. Some existed just a few 100 million years after the Big Bang, when the universe was still in its childhood. Their presence surprised astronomers, as if stars and galaxies learned to gather much faster than theory predicted. How could so much order emerge from so recent a dawn? The answers ripple outward still. Perhaps gravity worked differently in those early times. Perhaps dark matter, that invisible web that shapes the universe, was denser, pulling matter together more quickly. Or perhaps we are only now beginning to glimpse how efficient creation can be when the conditions are perfect, when hydrogen, helium, and time dance to the rhythm of expansion. Webb's eyes are sensitive enough to detect light from galaxies like GNZ11, one of the oldest ever observed aglow from just 230 million years after the Big Bang. In cosmic terms, that's almost the first breath. And yet, GNZ11 is already a galaxy structured, bright, alive. Its discovery reshaped our understanding of how quickly the universe learned to build. Every pixel of Webb's images carries a story measured not in miles but in centuries. Light curves, bends, and stretches under gravity, a phenomenon we call gravitational lensing. When Webb peers through massive clusters of galaxies, their gravity acts like a magnifying glass, bending the light from galaxies behind them. The result is a reflection of the distant past, arcs of light smeared across the frame, the ghosts of worlds billions of years old. Webb's instruments read that light like a poem, each wavelength a syllable, each color a word. From it, scientists can tell what elements are present, how fast a galaxy is moving, how old its stars are, how distant it lies. Infrared light becomes a kind of language translating the silent history of the cosmos into something we can finally understand. And yet, as we read these ancient stories, another truth emerges. The further we look back, the more we realize how intertwined we are with all of it. The same physics that shaped those early stars shapes our own atoms now. The same forces that forged galaxies govern the space between your thoughts and your breath. When Webb peers into the deep past, it is also looking inward into the ancestry of existence itself. Think again of that telescope floating 1,000,000 miles from home. It does not orbit Earth like Hubble once did. It orbits the balance between Earth and Sun, its golden mirrors always turned outward. It never sees sunrise or sunset, only the cold brilliance of the cosmos. It drifts in a zone of near-perfect equilibrium, its instruments cooled to near absolute zero, so that its own heat does not interfere with the faint warmth of distant light. In that stillness, it waits for photons that left their galaxies before our world began, for whispers that cross the boundaries of time, for echoes of the Big Bang still shimmering at the edge of perception. What Webb shows us is not just the past, it's the continuity between past and present. The same expansion that began in the Big Bang carries on. The same laws that governed the first hydrogen clouds still shape our oceans and our sky. We are each of us small reflections of a larger pattern. And so the telescope, though made of metal and mathematics, becomes something deeply human. It is our curiosity given form, our longing for connection stretched into space, our desire to know not just how things began, but why they continue at all. Sometimes astronomers describe Webb's mission as a search for origins, the origins of galaxies, of stars, of planets, of life. But there is another way to see it. Webb isn't just looking backward in time. It's reminding us that time itself is a bridge, that everything we see is a continuation of the same act of creation. The light from those early galaxies hasn't stopped traveling. It's still arriving, still crossing the silence, still entering our eyes and our instruments. We live in a universe that is always revealing itself, one photon at a time. And Webb, with its gold mirrors and patient gaze, teaches us that looking outward is another way of coming home. Because what it finds, those distant galaxies, those early stars, those ancient traces of light, are the same things that make us possible. To look deep into the cosmos is to look at the memory of our own beginning. As you rest now, imagine Webb floating through that stillness. Imagine its mirrors catching faint ancient light that once shimmered across the first stars, now arriving softly at the edge of its vision. Each photon that touches its sensors carries a story older than the Earth, and each one helps us see a little more clearly what it means to exist at all. In its quiet orbit, Webb does what we too do every night when we look up. It listens. It waits. It wonders. The stars it observes are gone, long faded, their light stretched across eternity. But their presence endures, transformed into information, into beauty, into understanding. It reminds us that even the faintest trace of light never truly disappears. It only travels, changes, softens. and so perhaps do we. The universe keeps its secrets gently, and sometimes to understand them, we must build a mirror not just to capture light, but to reflect wonder. Through Webb's gaze, we learn that the edge of space is not a line, but a threshold, a place where time bends and the past becomes visible again, a place where creation and memory meet, and from that meeting, a new kind of awe unfolds. From the quiet orbit of the James Webb Space Telescope, our view drifts backward through time, past the spirals and clusters of galaxies that shape our cosmic neighborhood, past the faint red glow of galaxies forming just a few 100 million years after the Big Bang, back into a time before stars, before metals, before color itself existed. The light Webb sees from those distant ages has traveled longer than life has existed on Earth. Each wave, stretched thin by the universe's expansion, softened to a faint ancient warmth. Through that light, we trace the story of the first stars, the population 3 stars as astronomers call them. They were the pioneers of existence, the first lamps in a universe that had known only darkness. Their birth was quiet at first. Clouds of hydrogen and helium drifted through a still young cosmos, guided by gravity's slow and patient hand. Wherever the invisible filaments of dark matter were densest, matter began to collect. Tiny fluctuations, ripples left over from the earliest moments of expansion, gathered gas into knots. Each knot grew heavier, warmer, more compact. And eventually, the balance between weight and heat tipped toward brilliance. A single point ignited, then another, and another, until the dark began to shimmer with light. These first stars were not like our sun. They were titans, immense, short-lived, wild. Many were hundreds of times more massive than anything that shines today. Their cores blazed at temperatures that would tear atoms apart, burning their fuel in a few brief cosmic moments. Some may have lived only 1,000,000 years, a heartbeat in universal time, before collapsing into black holes or exploding in dazzling supernovae. They formed from purity, from the simplest elements the Big Bang had left behind, hydrogen and helium. There were no heavier elements yet, no carbon, oxygen, or iron to cool the gas or seed new chemistry. Theirs was a light of primal simplicity, white, blue, and fierce, unsoftened by dust, unfiltered by age. If you could have stood near one, the sky would not have been sky at all. It would have been an ocean of radiance, a storm of ultraviolet light tearing the last remnants of fog from space. The death of those stars was not an ending, but a beginning. In their cores, the first alchemy took place. Hydrogen fused into helium, helium into carbon, and oxygen, heavier and heavier elements forged under pressure and flame. And when those stars died, they scattered those elements into space, the first metals, the first ingredients for planets, oceans, and life. Their explosions seeded the cosmos with the raw material for everything that followed. The light from those explosions still travels. Some of it faint and stretched drifts through the field of the James Webb Space Telescope even now. Each photon a message written billions of years ago, whispering of the moment creation diversified itself. It's strange to think that our own atoms once belonged to those forgotten suns. The calcium in your bones, the iron in your blood, the oxygen that fills your lungs as you breathe slowly now. All were born in their brief, magnificent lives. You are made of ancient light, recycled stardust, reshaped into thought and heartbeat and memory. Astronomers have searched for direct evidence of these population 3 stars for decades. They are too far, too faint, too old to see clearly. Even Webb can only glimpse their aftermath, the galaxies they formed within the patterns of their chemical traces left behind. When Webb observes certain distant galaxies and finds them unusually pristine, devoid of heavy elements, it may be witnessing the ghost of that first generation. Galaxies whose light shows only hydrogen and helium untouched by time's enrichment. Somewhere out there in that faint red glow might be the fingerprints of the first suns that ever lived. They are not visible as individual stars, but their story is etched into the cosmic background, the subtle balance between brightness and absence, the faint outline of structure against the void. To imagine them, picture a night before nights existed. No planets, no moon. Only the raw materials of existence suspended in silence. Then gradually pinpricks of light flicker into being. They appear scattered at first lonely embers in a dark sea. But with each new birth, their light overlaps. Their radiation reshapes the surrounding space, ionizing the fog that once cloaked the universe. It's as if the cosmos is inhaling for the first time. Each photon a breath of awakening. The age that follows is sometimes called the epoch of Ryanization, the era when light reclaims the dark. As these first stars burn and die, they transform the universe from opaque to transparent, allowing light to move freely once more. Webb's instruments now collect the red-shifted echoes of this transition, faint signatures of that first cosmic dawn. And yet, even as the stars illuminate, they also create shadows. Their fierce radiation heats the surrounding gas, making it harder for new stars to form. For a while, creation pauses a tension between gravity pulling inward and light pushing outward. It is a delicate balance, and within that balance, complexity begins to emerge. Small galaxies merge into larger ones. Clusters of stars form gravitational families, the first galactic cores. The universe learns to build, from simplicity structure, from chaos order, from heat the coolness required for life. The cycle repeats endlessly. New stars born from the ashes of the old, each generation adding more heavy elements to the interstellar mix. Carbon for molecules, oxygen for water, silicon for stone, iron for blood. In this way, the universe becomes self-enriching, a cosmic memory system where every death writes the instructions for future life. Think of how fragile that process is and how inevitable it feels. Each step in the chain follows from the last, governed by laws that never rush, never rest. Fusion, collapse, explosion, expansion, cooling, each motion feeding the next like the rhythm of a great breathing. The first stars are gone, but their pattern remains. Every star you see tonight, every flicker across the black, carries within it the legacy of those ancient fires. They are the grandparents of the cosmos, unseen yet everywhere. And yet there's still mystery. What came before even them? Could there have been smaller pockets of light, or faint flashes of energy, or invisible matter condensing without ever igniting? Could some of those early collapses have formed the first black holes? silent seeds at the centers of future galaxies. Some theories suggest that the deaths of population 3 stars left behind enormous black holes millions of times more massive than our Sun, the ancestors of the supermassive black holes we see now. Others imagine that some stars collapsed directly into those voids without exploding, folding light inward instead of releasing it. Whatever the truth, one thing remains clear: the universe was already learning to organize itself. It was already experimenting with balance, with symmetry, with rhythm. And from that rhythm, all structure arose. If you picture the universe as a living being, then those first stars were its heartbeat, each one pulsing into existence, radiating energy outward, setting a tempo that continues to this day. The galaxy's web seas, now spirals of light curling through deep time, are the echoes of that first rhythm, still expanding, still resonating. The silence between those early stars wasn't empty either. It was filled with potential, with invisible matter that neither glows nor absorbs light, but exerts gravity nonetheless. That invisible presence shaped the filaments along which galaxies formed, weaving the cosmic web. Even in the earliest light, dark matter's hand was already guiding the pattern. Later, we'll speak of it again, of dark matter and its mysterious partner, dark energy. For now, it's enough to remember that even in the simplest beginnings, mystery and clarity are inseparable. The universe is both known and unknowable at once, a paradox of transparency and concealment. And perhaps that's what makes it so soothing to think about before sleep. There's comfort in knowing that everything, even the stars themselves, began as something invisible and uncertain. There's peace in remembering that creation takes its time. Somewhere, the light from those first stars is still moving, crossing the cold between galaxies, passing through clouds of dust, whispering the story of how brightness began. It travels forever, softening as it goes, until one night in one small world it reaches your eyes. It becomes wonder. It becomes thought. It becomes you lying here listening. And even as you listen, galaxies continue to form, collapse, and renew themselves. Stars continue to die, scattering the seeds of new creation. The same cycles that began in the first billion years continue tonight, above your roof, above the air itself. Nothing has stopped since that first ignition. Everything that exists moves still quietly, endlessly, gracefully, guided by the same laws, the same symmetry, the same quiet purpose. In the end, the story of the early universe is not a story of fire and chaos, but of transformation. It's the story of how light found its voice, of how matter learned to glow, of how silence became song. So as Webb peers deeper into that origin, and as we gaze alongside it, we are reminded of something essential, that we too are part of that unfolding. We are not separate from the stars. We are their continuation, their living memory, their ongoing experiment in awareness. Even as the telescope looks outward, we look inward, following the same path of curiosity that began when the first hydrogen atom met another in the quiet dark. The story has no true beginning and no final edge. Only transitions, only light finding new forms to inhabit. Somewhere, perhaps in the faintest galaxies, Webb will ever see a remnant of a population 3 stars explosion. Still drifts, a grain of carbon dust, a fragment of oxygen ice, a particle of iron, spinning slowly through a nebula. And one day, perhaps that dust will gather, again form a planet, form a living being, form another consciousness, wondering the same question: what lies beyond the edge of space? And so the cycle continues endlessly, creative, endlessly reflective. Light becoming matter, matter becoming life, life becoming wonder. The story continues as it always does, through shadow and through light. From the brilliance of the first stars, our gaze moves toward what cannot be seen. Because for all the glowing galaxies Webb observes, for all the burning suns and radiant clouds of gas, there is far more that remains hidden. The universe, luminous as it seems, is mostly made of darkness. And yet, that darkness is not empty. It is structure. It is force. It is the quiet architecture that holds everything in place. Astronomers call it dark matter, not because it is sinister, but because it does not shine. It neither emits nor absorbs light. It simply is. Invisible but tangible in its effects. Every galaxy we see spins because of it. Every cluster of stars holds together within its unseen gravity. Without it, the stars would scatter into the void like sparks blown from a dying fire. It is strange to think that something we cannot see defines the shape of what we can. Every spiral, every cosmic thread, every curve of starlight follows the pull of dark matter's invisible hand. It forms a vast web that stretches across the cosmos' filaments, and nodes connecting galaxies like dewdrops caught in the threads of a cosmic net. Between those filaments lie immense voids, regions almost empty of matter at all. And yet even emptiness follows the pattern that darkness weaves. If you could see the universe in dark matter, it would look like lace, glowing galaxies scattered along threads of gravity, their light tracing the unseen design beneath. We live in one of those threads. Our own Milky Way is suspended in that web, turning slowly, held by something we can feel but never touch. Scientists have spent decades trying to understand what dark matter truly is. They've built detectors deep underground, shielded from the noise of cosmic rays. They've watched for collisions that never happen, searched for particles that leave no trace. Each experiment reaches into silence, hoping the silence will answer back. And yet it never does not directly. The particles that make up dark matter, if they exist as particles at all, are shy beyond comprehension. They pass through us constantly, through your body, now through the air, through the earth itself, billions each second, unnoticed and unharming. They do not reflect, they do not resist, they do not speak. But together they hold galaxies together like invisible glue. Dark matter is the framework of the cosmos, a scaffolding upon which all visible matter gathers. Without it, the early universe would have been too smooth, too evenly distributed. Gravity alone from visible matter could not have built galaxies so quickly after the Big Bang. But dark matter, dense, cold, and patient, pulled hydrogen and helium into clumps. Those clumps became the first stars. And from those stars came us. So in a sense, dark matter is not just the hidden skeleton of the universe. It is our ancestor too. It humbles us, doesn't it? To realize that everything familiar, the sun, the planets, the air, our own cells, makes up less than 5% of all there is. The rest, the vast remainder, is unseen. Roughly 27% is dark matter, and the rest, nearly 68%, is something stranger still, something even less understood, something called dark energy. If dark matter holds the universe together, dark energy pulls it apart. It is the gentle but persistent force causing the cosmos to expand faster and faster. At first, scientists assumed gravity would slow the expansion over time. But in 1998, observations of distant supernovae revealed the opposite galaxies are not slowing down. They are speeding away from each other. Space itself is stretching, and the rate of that stretching is increasing. That discovery changed everything. It suggested that the vacuum of space, the emptiness between stars, is not truly empty. It hums with energy, faint but constant, a pressure that pushes the cosmos outward. No one knows exactly what dark energy is. It might be a property of space itself, an inherent urge to expand. Or it could be something deeper, a field, a balance, a tension between dimensions. Whatever it is, it now defines the destiny of the universe. If dark energy continues its steady acceleration, galaxies will drift further and further apart. Stars will fade beyond visibility. The night sky will grow emptier, quieter. And in the far future, only local clusters, small islands of light, will remain gravitationally bound. The rest will slip beyond our cosmic horizon, unreachable forever. But that is a distant chapter. For now, dark energy is gentle, subtle, the faintest hum beneath the symphony of stars. It does not interrupt, it expands. It does not destroy, it unfolds. And in doing so, it ensures that the universe remains in motion. So we find ourselves in a strange position. We live in a universe where what we see is not most of what exists. The visible cosmos, every star, every galaxy, every shimmering nebula, is the surface of something larger, deeper, quieter. Like frost on a window, it reveals only the thinnest layer of a hidden design. Webb's golden mirrors, sensitive to the faintest light, help us trace that design. By observing how galaxies move, how they cluster and twist, we can infer the presence of dark matter beneath them. By measuring how that clustering changes over time, we can estimate how dark energy pushes them apart. Each observation is a fingerprint of the unseen. Each beam of light a map of gravity's invisible tide. Imagine this. A galaxy seen by Webb appears distorted, its light bent into arcs. The bending is caused not by the galaxy itself, but by a massive halo of dark matter surrounding it. The gravity of that halo bends space-time, curving the path of light from more distant galaxies behind it. This is gravitational lensing, nature's own magnifying glass, a tool that lets us glimpse even deeper into the cosmos. Through these cosmic lenses, Webb reveals galaxies too faint to be seen. Otherwise, tiny smudges of red that existed when the universe was less than 1 billion years old. Each one is evidence of the interplay between dark matter's pull and dark energy's push, the eternal dance of structure and expansion. It is easy to think of darkness as absence, but here it is presence, active, dynamic, full of consequence. It sculpts the galaxies. It drives the future. It defines what space even means. Dark matter gathers. Dark energy disperses. One pulls inward, the other stretches outward. Between them lies balance, the fragile middle ground where life can exist, where stars can form, where wonder can bloom. If you listen closely, you can almost hear the symmetry of it. Gravity's slow, deep tone countered by expansion's long, rising hum. Two forces, opposite but inseparable, shaping the rhythm of eternity. And somewhere within that rhythm, a quiet planet orbiting a modest star, thinking about it all. We sometimes forget that understanding darkness is also a form of light. When we name the unknown, we give it presence. When we study the unseen, we bring it closer. The term dark does not mean hopeless. It simply means we have not yet learned to see. Perhaps that's what the universe is teaching us, that mystery is not failure, but invitation. That every shadow holds meaning if you wait long enough for your eyes to adjust. There are theories, of course. Some physicists imagine dark matter as exotic particles, WIMPs, axions, sterile neutrinos, names for possibilities not yet proven. Others think it may not be particles at all, but a feature of gravity we do not yet understand, an unseen curvature in space-time itself. Dark energy, too, might not be a separate substance. It could be the energy of the vacuum, the gentle pressure of quantum fields at rest. Or it might be something we can't yet conceive, a property that only makes sense in a universe that's still learning to expand. Whatever the explanation, these forces remind us that the cosmos is not fully revealed. No telescope, however perfect, can yet see everything. There are limits, horizons, boundaries not of distance but of understanding. And those limits are not discouraging. They are comforting. Because they mean there will always be something left to discover, always another horizon beyond the one we've reached. Think again of the James Webb Space Telescope floating in its patient orbit. Every image it captures is a conversation between light and darkness. Every photon it receives has fought its way across billions of light years, bent and stretched by invisible fields, guided by gravity we cannot see. When those images reach us, bright galaxies, swirling dust, glowing clusters, they are not just pictures. They are evidence that the invisible world is working quietly and perfectly, holding everything together. So, the next time you look at the night sky, whether through a telescope or through your own window, remember that the stars are only the surface of a deeper whole. Beneath the shimmer lies a lattice of gravity, unseen but essential. Beyond the shimmer lies a pressure that keeps the lattice expanding. Everything we are, everything we know, exists between those two forces. Dark matter holds us. Dark energy carries us, and together they let the universe breathe. As you lie still, perhaps feeling the gentle rhythm of your own breathing, imagine that you are synchronized with that same cosmic inhale and exhale. The rise and fall of your chest mirrors the expansion and pull of the universe itself. Every breath a small echo of creation. Every heartbeat a reflection of gravity's steady rhythm. The light of the first stars fades softly behind us now, and ahead stretches the dark fabric that sustains all things. Invisible but certain. Quiet but infinite. And within that, quiet, galaxies drift, stars burn, and life wonders. Not in defiance of the dark, but because of it. Darkness holds the universe together, and light reveals its shape. They exist as partners, opposites intertwined, like the inhale and exhale of creation itself. Through dark matter's gravity, galaxies form. Through dark energy's expansion, they drift apart. And through light, we learn what those motions mean. Light is the language of the cosmos. Every star, every quasar, every particle that ever glowed has written its story into it. But light is not constant. It changes. It stretches, softens, and shifts as it travels through the widening fabric of space. That stretching, that gentle lengthening of wavelength is called redshift. It is the universe's way of telling time. When light first leaves a star, it vibrates in a pattern unique to that moment, its wavelength defining its color. But as space expands, the light traveling through it is stretched along with space itself. The wave grows longer, redder, older, and by the time it reaches us, billions of years later, it carries within it the record of that journey. Light, therefore, is more than brightness. It is memory, a moving archive of everything that has ever burned. To understand redshift is to understand how we see the past. When you look at the moon, you see it as it was 1.5 seconds ago. When you look at the sun, you see it as it was 8 minutes ago. When you look at the nearest star beyond the sun, Proxima Centauri, you see it as it was more than 4 years ago. And when Webb looks deep into the field of galaxies, it sees light that began its journey more than 13 billion years ago, light that started moving when the universe itself was young. The universe has no mirrors, only delays. Every photon is late to its destination. Every glimmer arrives bearing the weight of time. So when we gaze across the night sky, we are not looking outward. We are looking backward. Each star is a story already finished its ending, written in wavelengths stretched by expansion. It's almost poetic that the deeper we look, the younger the universe appears. In one image, we see all of history layered together, galaxies near and mature, galaxies far and infant, galaxies so distant that their light has barely reached us, trembling at the threshold of visibility. Each distance corresponds to a redshift, a measure of how much the universe has expanded since that light began its voyage. The idea seems simple. Light stretches, color changes, time passes. But within that simplicity lies the measure of everything, the proof that the universe is expanding, the evidence of its age, the rhythm of its breath. When astronomer Edwin Hubble first plotted the redshifts of galaxies in 1929, he found that nearly all of them were moving away from us. The farther they were, the faster they receded. This became Hubble's law. The first clear sign that space itself is growing. It's a quiet expansion. Not galaxies rushing through space, but space itself widening between them. Imagine dots on a balloon. As the balloon inflates, the dots move apart, not because they travel, but because the surface expands. Now imagine that expansion in 3 dimensions everywhere in all directions at once. There is no center, no edge, no direction of travel, only a deep, steady unfolding. Redshift is the color of that unfolding. It tells us not only how far away something is, but how long its light has been on the road. It lets us build a map, not of space, but of time. A map that stretches from this very moment all the way back to the first dawn. When the James Webb Space Telescope looks into the dark, it measures that redshift precisely. By analyzing how much a galaxy's light has been stretched, Webb can determine its age. how soon after the Big Bang it formed, how quickly its stars were born, how swiftly its structure took shape. Some galaxies Webb has seen are at redshifts beyond 10, meaning their light began traveling when the universe was less than 500 million years old. Each one is a fossil made of photons. There's something deeply moving about that. Every beam of ancient light that touches Webb's sensors carries within it billions of years of solitude. It began as a flash in a newborn galaxy, perhaps from a dying star, perhaps from a collision, perhaps from a simple ripple of cosmic gas, and then it traveled alone across expanding emptiness. It passed through fields of dark matter, through clouds of hydrogen, through regions where galaxies had not yet formed. And then, after all that distance, it arrived faint red, trembling at a mirror of gold and glass built by hands that evolved from the dust of those very stars. In that moment, the universe looks back at itself. Redshift turns space into a kind of melody, each wavelength a note that deepens as time expands. Blue light becomes red. Red fades into infrared. Infrared becomes heat. And beyond that, invisible whisperings that no human eye can detect. Light slows in its vibration as the universe ages, as though the cosmos itself exhales, and the sound of that breath grows lower, softer, longer. Even now, the light from the farthest galaxies continues to stretch. Their color slips toward the infrared. Their brightness dims. Their message grows faint. Eventually, their light will move beyond what any telescope can perceive, fading into wavelengths longer than time allows us to measure. And still it will travel. There is no wall, no end, only the deep quiet of continual motion. In the early universe, redshift did not just record time, it helped shape it. As space expanded, radiation cooled. The cosmic microwave background, that faint afterglow of the Big Bang, is light redshifted to near invisibility. Once, it was white-hot, a blinding fog of photons and plasma. Now, it is a ghostly hum, a uniform whisper at just 2.7 degrees above absolute zero. Each photon in that background is a time capsule, preserving the conditions of the universe when it was only 380,000 years old. Through redshift, we can reconstruct the universe's childhood, adolescence, and ongoing growth. We can trace when galaxies began to form, when stars began to cluster, when the cosmic web began to weave itself. It is as if we are reading the diary of the cosmos written in wavelengths that only now reach our page. But redshift is more than measurement. It is a reminder of impermanence. It shows us that even light, the fastest thing in existence, cannot escape the slow hand of change. Everything stretches, everything cools, everything drifts away. And yet, in that drifting there is beauty, because the stretching of light is what allows us to see the past at all. If light did not redshift, we would be blind to history. We would see only the immediate, only the now. But because the universe expands, every photon carries a record not only of distance, but of age. The redder the light, the older its memory. So the universe, in a way, is always whispering its own story. It's comforting to think of redshift as a natural consequence of expansion, but you can also think of it more personally. It's the universe's way of slowing its voice for us. Like a teacher speaking softly, letting each word stretch long enough for us to understand. Every wave of light lengthened by the growth of space is a cosmic gesture of patience. And Webb listens with that same patience. Its mirrors do not simply capture light, they interpret silence. Every image, every faint smear of color on a digital sensor is a translation of ancient motion into human comprehension. In the blackness, where there is no sound, light becomes language. Even closer to home, redshift and its counterpart, blueshift, tell the story of motion. When an object moves away, its light stretches redshift. When it moves toward us, it compresses blueshift. The light from Andromeda, our nearest galactic neighbor, is blueshifted. It is coming closer. One day, in about 4 billion years, our galaxies will meet and merge. The light of their stars will blend. Their dark matter, halos, will entwine, and a new galaxy will be born, an elliptical echo of both. Even in that future collision, redshift and blueshift will tell the tale, wavelengths stretching and compressing in a cosmic duet, a record of motion written in color. In this way, light never lies. It cannot conceal what it has endured. It carries the fingerprints of gravity, the signature of time, the echo of every encounter it has had along the way. Astronomers decode these fingerprints through spectroscopy, spreading light into its rainbow of components and reading the patterns like a barcode. In those patterns lie truths about temperature, speed, composition, distance, and age. Through redshift, the universe tells us not only how far it has traveled, but how long it has been becoming. And yet beyond the numbers and graphs, there is poetry. There is the quiet realization that we too are part of this ongoing shift. We exist within the same expanding space carried along with every galaxy, every star, every particle of dust. We are red-shifted beings slowly moving away from everything else, yet still connected by the light that bridges the distance. As the universe grows, our own lives move in rhythm with it. Our moments lengthen, our memories fade and soften. We too are light stretched across time, experiences turned into recollection, recollection turned into story. Each of us, in our own way, is a tiny vessel of ancient light, carrying the past into the present, shining briefly before dissolving back into the cosmic sea. Redshift teaches us that the past is never truly gone. It just moves further away, traveling into longer wavelengths of remembrance. And so even the light that once touched the first stars is still here, softened, but enduring, woven into the background of existence. It moves through you now, through the air. You breathe through the quiet in this very moment. Somewhere out there beyond Webb's reach, light from galaxies we will never see is still traveling. It will continue long after our own stars have faded, long after Earth has cooled, long after memory itself becomes silence. And in that endless journey, it will carry the story forward, the memory of expansion, the signature of being. Light stretches, time deepens. The universe continues its slow unfolding. And through redshift, we can still listen to a past that is always receding and a future that is always forming. Light stretches across the widening universe, carrying time within it. Through that soft redshift, we glimpse the memory of creation, the first stars forming the first darkness, giving way to fire. But the story does not stop at single stars. Stars gather. They drift into patterns, families, constellations of gravity and light. They learn in the silent motion of space how to belong to one another. From those gatherings, galaxies are born. They are not just collections of stars. They are ecosystems of matter and motion, balanced by forces that never sleep. They are the great cities of the cosmos, each containing billions, sometimes trillions of suns. Their shapes vary, spirals of calm precision, elliptical swarms of old stars, and irregular clouds where chaos still reigns. Every galaxy is a story of time and gravity written in light. The earliest galaxies were small, fragile things. They formed just a few 100 million years after the Big Bang, when the universe was still young and hot. Hydrogen and helium gas fell into the invisible wells of dark matter, cooling, condensing, forming stars that lit the darkness. At first, they were faint, tiny beacons scattered through vast expanses of nothing. But over billions of years, they grew, merging with one another, weaving the cosmic web we see today. If redshift allows us to look backward through time, then galaxies are its milestones. Each one a frozen moment in the universe's long evolution. Each one a marker on the path between the first light and now. When the James Webb Space Telescope looks deep into the field of galaxies, it sees the earliest versions of these systems, small dents bursting with new stars. Some appear when the universe was only 200 or 300 million years old. They are surprisingly mature, already showing structure, already spinning. Their existence tells us that galaxy formation began much earlier than we once thought. The cosmos, it seems, wasted no time in learning how to create beauty. To imagine a young galaxy is to imagine light learning to organize itself. Hydrogen gas gathers, collapses, ignites. Massive stars form live fast and die in bursts of energy. Their explosions send shock waves through space, triggering new generations of stars to form. Supernova after supernova, each death planting the seeds of life, each rebirth adding new layers of complexity. In this way, galaxies evolve as living things do through cycles of creation and renewal. Some galaxies become spirals, elegant disks with bright, rotating arms curling outward like slow waves. At their centers lie bulges of older stars, steady and golden, surrounded by clouds of gas that form new stars along the arms. Our own Milky Way is one of these spirals, a delicate balance of order and motion, spinning once every 230 million years. If you could see it from afar, you would see light flowing through its arms, like water in a celestial river, calm, rhythmic, endless. Others become ellipticals, vast smooth spheres of old stars glowing faintly in the quiet. They are the veterans of the universe, remnants of ancient collisions where spirals merged and their orderly arms dissolved into stillness. No new stars form there. The gas has been used or scattered. They drift in silence, faded golden lanterns from the early epochs of creation. And then there are the irregular galaxies, the ones without clear form, scattered fragments shaped by gravity's accidents. Some are small and fierce, burning with young stars. Others are broken, torn by tidal forces from nearby galaxies. Their beauty lies in their unpredictability, their refusal to settle into symmetry. Each shape tells a story not of perfection, but of process. No galaxy is static. All are in motion, evolving slowly across billions of years. They collide, merge, dissolve, and rebuild their lives, measured not in centuries or millennia, but in cosmic ages. Even our Milky Way, serene as it seems, is not permanent. In about 4 billion years, it will merge with the Andromeda Galaxy, two spirals intertwining in a slow, luminous dance. Their arms will stretch, their stars will scatter, and together they will become something new. Perhaps a giant elliptical, soft and diffuse, glowing with the blended light of countless suns. The same laws that shaped those galaxies govern the smallest grains of matter within you. Gravity binds them. Time changes them. Motion gives them rhythm. You too are a small galaxy of particles, a spiral of light and memory, bound within the dark matter of your own thoughts. You too are evolving, quietly, endlessly. But how do galaxies grow from chaos into structure? How does randomness find balance? The answer lies in gravity, that patient sculptor of the universe. Every particle, every atom, every star pulls on every other. In the vast emptiness, these tiny pulls accumulate, drawing matter together over eons. Gravity is not forceful. It is persistent. It works not through speed, but through endurance, shaping space one heartbeat at a time. As galaxies grow, they also feed. They draw in clouds of gas from intergalactic space, adding fuel for new stars. They consume smaller galaxies, absorbing their stars and energy. Collisions between galaxies may seem destructive, but they are actually creative. When two galaxies merge, their gas compresses and ignites, triggering bursts of star formation, millions of new suns born from the meeting of two ancient systems. Out of collision comes creation. Out of chaos, order. This process of merging and renewal continues even now. In the night sky, when we look toward the constellations of Virgo or Fornax, we see clusters where hundreds or thousands of galaxies gather. Their light blends into a mist of gold and red, each point a world of worlds. Gravity binds them together, but dark energy gently pushes them apart. The balance between those forces, one pulling inward, one stretching outward, defines the rhythm of galactic life. Galaxies also evolve internally. Stars are born in clouds of gas, live for millions or billions of years, and then die, releasing their elements into space. New stars form from that material, carrying forward the memory of the old. In this cycle, galaxies enrich themselves. They become chemical laboratories, turning hydrogen into the complex palette of elements that make up everything from oceans to breath to thought. The light we see from galaxies is not just beauty, it is chemistry. It is the record of fusion, the transformation of simplicity into diversity. Every color, every spectrum Webb captures tells us what those galaxies are made of and how they have changed. Through that light, we can see the history of enrichment from pure hydrogen to carbon, oxygen, silicon, iron, the vocabulary of existence itself. In this way, galaxies are teachers. They remind us that growth is not instantaneous. It requires collapse and expansion, gathering and release. It requires patience, a kind of cosmic mindfulness. Each era of star formation adds a new layer to their story, a new texture to their glow. And when you look at the night sky, you are seeing not just the light of stars, but the accumulated wisdom of billions of years. Some galaxies harbor mysteries even deeper. At their centers, Hidden behind veils of dust and radiation lie supermassive black holes, objects so dense that not even light can escape their pull. We do not yet know exactly how these giants form. They may begin as remnants of the first massive stars, or as direct collapses of primordial gas. Whatever their origin, they grow with their galaxies, shaping their evolution, regulating their brightness, influencing their rhythm. They are both destroyers and creators, consuming matter, yet driving the energy that makes galaxies shine. Our own Milky Way holds one Sagittarius A, a black hole about 4 million times the mass of our Sun. Around it, stars orbit at incredible speeds, tracing the invisible gravity that binds them. It sits at the very heart of our galaxy, a reminder that even within light darkness holds center. Through Webb and other observatories, we can see how these black holes sculpt their galaxies. When matter falls toward them, it heats and glows, releasing jets of radiation that shoot across thousands of light years. These jets stir the surrounding gas, sometimes preventing new stars from forming, sometimes triggering them anew. Balance, once again, creation and destruction intertwined. Over time, galaxies age. Their brightest stars burn out, their gas grows thin, their spiral arms fade. They settle into quieter forms, glowing softly with the accumulated light of old suns. In these elder galaxies, time itself feels slower, stretched, like the light that left them. They are the quiet end of a long, luminous story. And yet even in that stillness, nothing truly stops. Gravity continues its gentle work. Dark energy continues its slow push. New galaxies form in the distance, repeating the cycle endlessly. There is no final state, only transformation. The galaxies you see tonight are not the same as they were when their light began its journey. They have changed. They have merged. Some have vanished entirely. What you see is their memory preserved in photons that traveled across expanding space to reach your eyes. It is a humbling thought that the universe we observe is a memory, a recording of what once was still glowing as it drifts away. And yet, in that memory lies connection. For the same light that left those galaxies billions of years ago now mingles with the atoms in your body. You are made of their remnants. You are their continuation. So when you gaze at the Milky Way stretched across the night, know that you are seeing your own reflection, the ancient structure that gave rise to everything you are. Its spiral arms curve through your blood. Its dust lives in your breath. You are part of the galaxy's long evolution, a spark in the ongoing pattern of creation. Galaxies form. They change. They collide and heal. And we, resting under their distant light, continue their story in our own quiet way. Galaxies vast and luminous drift through the cosmos like slow-moving thoughts in the mind of the universe. Their light fills the great dark ocean of space, each one a living structure of gravity and time. And yet, at the very heart of these galaxies, at the centers of order and beauty, lies something profoundly quiet, something unseen, yet essential. A darkness so deep it bends light itself. A supermassive black hole. From the earliest galaxies Webb has seen, we know that these immense beings have existed almost as long as galaxies themselves. Even when the universe was young, less than 1 billion years old, supermassive black holes already rested in galactic cores, millions or billions of times the mass of our Sun. It is one of the universe's great mysteries how such enormous objects formed so soon after the dawn. Perhaps they were born from the collapse of the first massive stars, those short-lived population 3 giants whose violent deaths left behind heavy remnants that grew rapidly over time. Or perhaps they emerged directly from clouds of primordial gas collapsing under their own gravity before stars ever formed. However they began, they grew alongside their galaxies, locked in a delicate partnership that shaped the architecture of the cosmos. The connection between a galaxy and its central black hole is intimate. They are not separate entities, but 2 aspects of one system, 2 notes in the same cosmic chord. As the galaxy feeds the black hole with gas and dust, the black hole in turn influences the galaxy's evolution. Its gravity governs the orbits of stars near the center. Its radiation and jets regulate the birth of new stars farther out. In this exchange, creation and consumption become part of a single balanced rhythm. If you could approach one of these ancient galaxies, you would see a calm core glowing faintly, a region where matter swirls faster than anywhere else. Gas spirals inward, heating as it falls, glowing in X-rays and ultraviolet light. Around that center, the galaxy's arms stretch outward, filled with stars, planets, and nebulae, an ordered dance held together by an invisible conductor. And within that core, the black hole waits. It does not pull everything in. It does not devour without end. It feeds only when matter wanders too close, when a star strays from its path, when a cloud collapses into its reach. Even in its hunger, there is patience. Even in its gravity, there is stillness. The region around a feeding black hole is known as an accretion disk, a flattened ring of superheated gas swirling just outside the event horizon. As friction within the disk builds, it releases energy shining brighter than entire galaxies. From the poles of this disk, streams of particles may erupt, racing outward at near light speed, relativistic jets that pierce the intergalactic dark. These jets can stretch for thousands of light years, seeding the surrounding space with magnetic fields and energy. They are not destruction. They are renewal. They stir the gas in the galaxy, triggering new star formation, shaping the interstellar medium. Even a black hole, silent and consuming, plays a role in the act of creation. Astronomers believe that nearly every large galaxy, including our own Milky Way, contains a supermassive black hole at its center. Ours is called Sagittarius A, a calm giant about 4 million times the mass of the Sun, resting in the quiet heart of our galaxy. We cannot see it directly, but we can trace its influence. Stars orbit it with astonishing speed, completing full revolutions in mere years. Their motion reveals the gravity of something invisible, compact, and immense. In 2022, the Event Horizon Telescope, a network of observatories across the globe, captured the first image of Sagittarius A. What we saw was not the black hole itself, but the shadow it casts upon its own light, a glowing ring of matter circling an empty center, a portrait of nothingness luminous at its edges. It was strangely beautiful, a photograph of silence, the outline of an idea. That image, like Webb's deep fields, is more than a scientific achievement. It is a mirror of our own search for meaning, the desire to see the unseen, to find form within mystery. Supermassive black holes are often misunderstood. We imagine them as cosmic voids devouring all that approaches. But in truth, they are engines of transformation. Their immense gravity shapes galaxies. Their outflows spread elements across space. Their presence sets the tempo for star formation. Without them, galaxies might never have formed the way they did. Without them, we might not exist. When Webb peers deep into space, it detects the light of ancient quasars, galaxies whose central black holes are feeding intensely. These quasars shine brighter than entire star systems, their light traveling for billions of years to reach us. They mark the places where early black holes grew fastest, where matter and energy merged into brilliance. In them, we see both the ferocity and the grace of creation, the same balance that threads through every scale of the universe. The interplay between galaxies and black holes can be thought of as a conversation. The galaxy offers material, the black hole responds with energy, and through that exchange, both evolve. Sometimes the black hole's output is so strong that it halts the galaxy's growth, heating or expelling the gas that would have formed new stars. Other times, its influence compresses clouds of matter, prompting new stars to ignite. Push and pull, expansion and restraint. The same duality that governs dark matter and dark energy echoes again here within the heart of each galaxy. Over cosmic time, this conversation changes. Young galaxies rich with gas feed their black holes frequently. They glow with quasars and active nuclei. Older galaxies grow quieter, their fuel depleted, their cores serene. The balance shifts from chaos to calm. The universe itself ages in the same way, from turbulent youth to reflective maturity. Even now, our own galaxy continues that conversation. Sagittarius A is mostly dormant, but occasionally it stirs, emitting faint flares of X-rays and radio waves, reminders that the dark heart of the Milky Way is still alive. Its quiet presence anchors the galactic dance, holding us all in a slow, patient orbit. If you could stand far beyond our galaxy, perhaps on the edge of another spiral system, and look back toward home, you would see a glowing disk suspended in darkness. At its center, a soft radiance would mark the location of Sagittarius A. Around it, the stars of the Milky Way would turn like slow embers in a vast wind. And though you could not see the black hole itself, you would feel its symmetry, its still gravity, the calm at the center of motion. That stillness has a parallel in our own lives. Just as a galaxy needs a center, a point of balance around which it turns, so do we. Our minds too orbit invisible centers, memories, dreams, quiet intentions. They are not always visible, yet they guide the motion of everything else. The gravity of what we love, what we hope for, what we wonder about. These are our own black holes unseen, but shaping the light within us. Supermassive black holes remind us that creation and destruction are not opposites, but phases of one process. Stars fall and energy rises out. Matter disappears. Structure appears. The universe does not end in darkness. It renews itself through it. Even when a black hole consumes matter, that matter is not lost. Its energy is transformed, radiated into space, woven back into the cosmic fabric. In physics, as in poetry, nothing truly ends. Everything changes form. Somewhere out there, perhaps in the earliest galaxies, Webb has glimpsed a black hole is feeding right now, drawing in a stream of gas that glows as it falls. The light it emits will travel across the expanding universe, stretched into red, softened into warmth, until one day, billions of years from now, it reaches another world, another mind, another moment of wonder. Perhaps that being will look upward and see, in that faint red light, a question the same one we ask tonight. What lies beyond the edge of space? Even black holes, which seem to mark boundaries, are not truly edges. They are thresholds. Beyond the event horizon lies not an end, but a continuation hidden from our current understanding. The laws of physics, as we know them, pause there, waiting for new insight. And perhaps within that silence, the universe keeps its deepest truths not in the light, but in the dark. In the grand design, everything depends on everything else. Stars make black holes. Black holes shape galaxies. Galaxies give rise to stars again. Light and darkness weave together into an unbroken continuum. It is a relationship as old as time, one that repeats in every scale, from the motion of atoms to the expansion of the cosmos. As you listen, imagine drifting through that web of galaxies, spirals, turning ellipticals, glowing irregular clouds, pulsing softly. At the center of each, a silent heart of gravity beats. You move through their light as though floating through a sea of distant campfires, each one flickering across billions of years. Everywhere you look, the same pattern emerges, energy becoming form, form returning to energy. A cosmic cycle of breathing, vast and eternal. Somewhere, perhaps in another spiral galaxy far away, another supermassive black hole turns quietly in its sleep. Around it, stars rise and fade, planets form and crumble, civilizations may come and go. And yet, the galaxy remains balanced, radiant, evolving. The darkness at its center is not a void, but an anchor, the still point around which the light can move. So when you look at the night sky, remember that behind every shimmer of starlight, behind every cluster or nebula, there may be a hidden heart, a silence strong enough to hold an entire galaxy. That silence is part of you too. It lives in the space between your breaths, in the calm between thoughts, in the quiet awareness that watches the turning of the stars. And even now, as the universe expands, as galaxies drift apart, and black holes continue their patient work, the same balance endures. Darkness shapes light. Light reveals darkness. Creation and dissolution are never enemies. They are companions on the same path. The galaxies drift, each one carrying a heart of darkness and arms of light. But they do not drift alone. The universe, vast as it is, allows nothing to exist in true isolation. Gravity threads everything together gently, persistently, without rest. And through that web of attraction, motion leads inevitably to meeting. Galaxies collide, not suddenly, not violently, but slowly over hundreds of millions of years. They approach like dancers drawn toward one another by a rhythm older than time, their spirals intertwining their stars, mingling their gas clouds, merging into a single new form. To us, the word collision sounds like destruction. But in the language of the cosmos, it means transformation. When galaxies meet their stars do not crash into each other. Space between stars is far too vast. Instead, their orbits shift, their paths bend under gravity's mutual pull. Clouds of gas are compressed, triggering waves of star formation, bursts of light that ripple through the galactic arms. It is as though the encounter wakes something sleeping within them, urging creation to begin again. These starbursts are brief by cosmic standards, lasting perhaps a few 100 million years. But their impact endures. Thousands of new stars ignite, illuminating the aftermath of chaos. The collision reshapes both galaxies, turning disorder into pattern. In this way, gravity, that patient sculptor, uses even turbulence as a tool of harmony. Every major galaxy we see today bears scars of past encounters. The Milky Way itself is no exception. Its calm spiral arms, its bright central bulge, its halo of stars, all are remnants of earlier mergers. Our galaxy was not born as a single perfect structure. It grew through countless unions. Smaller galaxies drawn in their stars absorbed their histories woven into our own. And the process continues still. Even now, faint dwarf galaxies orbit us like companions, slowly being pulled apart and folded into the Milky Way's edge. Their stars stretch into delicate streams, long ribbons of light tracing invisible paths through space. In every direction, gravity is gathering, shaping, refining. Beyond our local cluster, collisions are common entire galactic families, blending and merging, creating vast elliptical galaxies at the centers of clusters. Each one the product of 1,000 cosmic meetings, a record of time written in starlight. What once appeared chaotic resolves over eons into new order. If you could watch such a collision sped up through billions of years, it would look like a dance, two spirals drawing near, twisting, flaring, and finally settling into calm. Their arms stretch and tangle, then fall back into symmetry. The chaos subsides, and a new equilibrium is born. It is not destruction. It is evolution. In the distant future, this will be our fate as well. The Milky Way and the Andromeda Galaxy are moving toward each other at about 110 kilometers per second. In roughly 4 billion years, they will begin to merge. At first, their halos will touch faint veils of gas meeting softly in the dark. Then their disks will begin to overlap, stars flung into new orbits, great arcs of gas pulled between them like bridges of light. From Earth, if there is anyone still here to see it, the night sky will transform. Andromeda will grow brighter, each century spreading across the heavens until its stars merge with our own. The sky will become a living painting of motion, billions of suns crossing paths, forming new constellations in slow motion. Eventually, the two galaxies will settle into one, a vast elliptical glow filling the local sky. The name Milkomeda has been given to this future union, a quiet fusion of names just as the galaxies themselves will fuse. Even then, the black holes at the centers of both galaxies will move closer, circling each other for millions of years before merging in a final burst of energy, a wave through space-time that will echo across the universe. It will be the last heartbeat of that long dance. And then once again, stillness. This patterned chaos leading to order, yielding to new creation, repeats across scales. It happens in galaxies, in stars, in atoms, even in the mind. It is the universe's preferred rhythm, the oscillation between turbulence and balance. What looks like disorder is often just the next step toward harmony. In the early universe, such collisions were even more common. Galaxies were smaller, closer together, their motions faster. The cosmos then was a crowded sea of glowing clouds, constantly shifting and merging. From those frequent interactions emerged the great galactic structures we see today: clusters, filaments, superclusters woven by countless encounters into the cosmic web. If you imagine looking at the universe from far above, you would see a vast network of light galaxies connected along threads of dark matter, their collisions marking the intersections of that web. At each node, gravity deepens its hold, creating new galaxies, new stars, new centers of order. And within each collision, smaller dramas unfold. As galaxies meet, their gas compresses into knots dense enough to birth new stars. Those stars form clusters, some bound together for billions of years, others drifting apart as time expands. Some stars wander too close to black holes and are torn apart, their light flaring briefly before vanishing. Others born from the same collision live long enough to form planets, oceans, and perhaps life. From the violence of motion, serenity eventually returns. The universe is not in conflict with itself. Every apparent chaos serves a purpose: to mix, to renew, to distribute energy and matter. Collisions blend the elements forged in earlier stars, ensuring that the next generation of worlds will have all the ingredients needed for complexity. Even our own solar system may owe its existence to such cosmic recycling, the heavy elements in our planet's crust. The gold in your bloodstream, the calcium in your bones, all born from the debris of ancient galactic encounters. Sometimes collisions leave visible traces, long tidal tails of stars stretching thousands of light years into space, like trails of phosphorescent foam behind a drifting ship. Other times the evidence is hidden, erased by time. But whether visible or not, the result is the same: gravity gathers, and the universe reorganizes itself. In this balance of chaos and order lies a truth both scientific and spiritual. Everything changes form, yet nothing is lost. Even destruction in the cosmic sense is creative. Every death is a doorway, every impact an invitation for light to return in new shapes. Consider the galaxies known as the antennae, about 60 million light-years away in the constellation Corvus. They are two spirals caught in mid-collision, their arms stretched into arcs of light that resemble insect wings. The name is poetic, but the reality is even more so. What we are seeing is creation in progress. Inside those luminous arcs, thousands of new stars are forming their collective light, bright enough to outshine entire regions of the universe. 100 million years from now, those two galaxies will have merged into one, and their violent beauty will have softened into quiet symmetry. Or think of the whirlpool galaxy M51, another example of cosmic interaction. Its spiral arms are defined, sculpted by the pull of a smaller companion galaxy nearby. That tidal influence triggers waves of star formation that ripple outward like spirals on water. Order born from gravitational dialogue. Even the most peaceful galaxies carry within them the memory of such storms. Every balance you see is the result of earlier imbalance resolved. Every stillness comes from motion, every clarity from the soft dissolving of what came before. It is easy when thinking of galaxies to imagine the universe as something vast and indifferent, but collisions remind us that even on the grandest scales, relationship is everything. Nothing exists apart from interaction. Gravity is the cosmos's language of connection. Each encounter, whether a merger of galaxies or the meeting of two atoms, is a conversation written in motion. And so the growth of order is not imposed. It emerges. The universe does not command balance. It allows it to arise naturally from the meeting of opposites. Darkness and light. Motion and rest. Attraction and expansion. Through their interplay, structure is born. When you look up at the night sky, you are seeing the outcome of billions of such meetings, a calm surface stretched over deep history. Every point of light is the product of collision, gravity, and time. And though we think of galaxies as distant, their stories are entangled with our own. The atoms in your body, the elements in your bones, were once scattered in galactic storms, then gathered again into life. The universe does not forget its parts. It rearranges them. Even our future is written into that same rhythm. When the Milky Way and Andromeda finally merge, perhaps new stars will form, and new worlds will rise. Perhaps life will emerge again to look upward and ask the same questions we do now. The cycle will continue collision into creation chaos, into calm darkness, into light. And in that endless dance, the universe remains what it has always been, a process of becoming, not a finished thing. It is not a machine, but a breathing organism growing, shifting, evolving toward greater complexity and harmony. Somewhere in the silence between galaxies, the faint hum of gravitational waves still moves outward from ancient mergers, ripples through the very fabric of space-time. They travel without sound, but their presence can be measured. Each ripple is a record of a meeting long past a reminder that even in vast emptiness, something once touched something else. So tonight, as you lie still and listen to the slow turning of the earth beneath the stars, imagine that you too are part of that motion. The same forces that draw galaxies together draw the tides to shore the breath into your lungs, one thought into another. Order and chaos flow through you as they do through everything else. Each heartbeat a small echo of a cosmic collision resolved into calm. In the great design, there are no accidents, only continuations. Every collision becomes part of a greater harmony. Every disruption, a new beginning. Galaxies merge. Stars are born. Light travels outward, carrying the memory of creation with it. And somewhere billions of years later that light reaches us asking softly to be seen. Galaxies merge. Order rises from chaos, and the slow architecture of the cosmos continues to unfold. But before there were galaxies, before even the first stars burned, the universe existed in a kind of quiet suspension, a darkness rich with potential. To understand what we see now, we must drift back through time once more. Back before the great collisions, before the spirals formed their arms, before light found a way to move freely. There was a moment, delicate and silent, when the first light of the cosmos began its journey, the cosmic dawn. The birth of illumination after ages of obscurity. It is strange to imagine that darkness once filled everything. Not the darkness of absence, but a thick and glowing shadow, the young universe dense with hydrogen, still opaque to light. Photons moved, but they could not travel far. They scattered again and again through the charged particles of the early cosmos, trapped in an endless ricochet. The universe was bright from within, yet no light could escape. Then slowly, as space expanded, it cooled. Atoms began to form binding electrons into stable orbits, allowing light to travel freely for the first time. That moment when the fog lifted left behind a faint echo, the cosmic microwave background, the afterglow of the Big Bang itself. A uniform whisper of radiation still bathing the universe today, still murmuring in every direction. But even then, after that first transparency, there were no stars yet to shine. For hundreds of millions of years, the universe remained dark, a long night, between the end of the primordial fire and the first kindling of starlight. This was the cosmic dark age, a time of quiet formation. Gravity gathered the first clumps of matter in visible scaffolds of dark matter, pulling hydrogen and helium into denser regions. No eyes existed to see it, but the stage was being set for creation. And then, after nearly 400 million years, the silence broke. Hydrogen clouds collapsed under their own weight, forming the first stars. Brilliant, massive, brief. They shone in ultraviolet light so intense that it rayonized the gas around them, clearing the fog, allowing light to roam freely through space once more. This was the cosmic dawn, the first sunrise of the universe. The light from those stars is unimaginably old. It has traveled for over 13 billion years, stretched by expansion, until it glows now in the faint red of the infrared. The James Webb Space Telescope, with its golden mirrors tuned to that ancient wavelength, was designed to capture this earliest glow to witness the first illumination of creation. When Webb gazes into deep time, it looks for these ancient beacons, galaxies so far away that their light began when the universe was still young, only a few % of its current age. Each photon that touches Webb's sensors has crossed almost the entire history of existence to reach us. Each one carries within it the signature of that first fire, the dawn that turned darkness into possibility. To visualize it, imagine drifting in endless space before light was born. There is no up or down, no horizon, only vast clouds of hydrogen waiting. Then, somewhere ahead, a glow appears, a single star igniting, releasing light into a world that had never seen brightness before. The light spreads outward, a fragile bubble in the dark, joined soon by others, until the bubbles meet and merge. The universe fills with illumination, expanding not just in size, but in awareness. For the first time, the cosmos sees itself. Astronomers call this period reionization, the era when the first starlight transformed the intergalactic medium from neutral to charged, from opaque to transparent. It was not a single moment, but a slow awakening unfolding over hundreds of millions of years. Galaxies formed, stars ignited, and the fog of hydrogen dissolved into the clear night we know today. That light, red-shifted by expansion, now glows faintly in the infrared spectrum, invisible to the human eye, but not to Webb's. When Webb peers into that range, it becomes a time machine, seeing not just ancient stars, but the very transition from darkness to light. Its images reveal the structure of those early galaxies, small, irregular, glowing intensely as their newborn stars pour radiation into the surrounding gas. These were the first builders, the first artists of cosmic structure. They sculpted space itself, carving transparency into the void. Their radiation broke apart atoms. Their gravity drew matter together, and their deaths seeded the first heavy elements. In their short, brilliant lives, they changed everything. To us, this light arrives as faint patterns, almost ghostly, yet they hold all of cosmic history within them. Each speck in Webb's deep field represents a galaxy. As it once was, billions of years ago, its stars just beginning to burn. And beyond even those galaxies, faint red, nearly lost in the background, lies the residue of the first illumination. The cosmic dawn was not only the beginning of light, it was the beginning of contrast, of difference, of complexity. Before that, the universe was nearly uniform, a calm sea of matter and energy. With the arrival of starlight came shadow, and with shadow came form. In light and darkness, the cosmos found the interplay it needed to grow. If you listen closely to the quiet of night, you might sense that rhythm, still the first alternation between brightness and stillness, the pulse that started everything. Even the faint starlight entering your eyes now is part of that same lineage, the unbroken chain of illumination stretching from the first stars to this present moment. The cosmic dawn also reminds us of fragility. The first light was easily extinguished. It flickered in a sea of cooling gas, surrounded by regions still dark and untouched. Each early galaxy was an island of radiance in an ocean of shadow, and yet slowly those islands expanded, connecting, merging, until the darkness was transformed into a transparent sea. Creation. It seems, always begins this way, not with sudden perfection, but with small, uncertain steps. A single spark in the dark, a faint beginning that grows, gathers, and spreads. The universe's story mirrors our own, from silence to awareness, from isolation to connection, from confusion to clarity. Even now, when astronomers study the faint background radiation left from that era, they are listening to echoes of that first awakening. Tiny variations in that ancient light, minute differences in temperature and density reveal how matter clumped together, how the seeds of galaxies were planted. In those ripples, the blueprint of everything to come is contained. The light from the cosmic dawn does not travel alone. It carries with it the memory of all that followed the birth of galaxies, the rise of stars, the shaping of space. Each photon, though it may seem small, is a messenger of eternity. Its journey through time connects the first dawn to every moment since. There is something deeply human in this idea. We too live by the light of beginnings, the first thoughts that shape a life, the first questions that lead to understanding. Our awareness unfolds in much the same way darkness first, then flickers of illumination, then connection and clarity. We are, in essence, small reflections of that cosmic process light, emerging from darkness, forever seeking to understand its own source. The cosmic dawn was also the origin of structure, the universe's first attempt to organize itself. Before it, matter drifted freely. Afterward, it gathered into filaments, clusters, and galaxies. From simplicity arose complexity, not imposed but inevitable. That transition marks one of the universe's most profound shifts, when energy learned how to build, when chaos discovered form. Even as light spread, it did not banish darkness completely. Darkness remained necessary, balancing, protective. Too much light would have burned away the delicate conditions that allowed galaxies to form. Too much darkness would have hidden them forever. The harmony of the cosmos lies in this balance, illumination and shadow, each shaping the other. If you imagine yourself drifting through that first dawn, you might see the universe as a vast field of faint orange glow, scattered with points of new light. Around you, hydrogen gas begins to shimmer, ionized by the ultraviolet radiance of the first stars. In the distance, you might sense the birth of the first galaxies, compact, luminous, their gravity shaping the surrounding void. The silence would be profound, yet filled with potential, a stillness humming with creation. This was the moment when the universe became visible to itself, and in that, seeing it began to change. Light revealed structure. Structure revealed possibility. Possibility gave rise to complexity, and eventually to life. From that first dawn, every star, every planet, every being is a continuation. Even the faint glow that fills the night sky today, the light of distant galaxies, is the long echo of that first illumination. It reminds us that creation is not a single event, but an ongoing process. Every new sunrise, every flicker of curiosity, every spark of understanding continues the work that began over 13 billion years ago. And as we study that ancient light, we learn not only about the universe's beginnings, but about our own nature. For we too are travelers in time, carriers of light stretched across the ages. The same photons that once touched the first stars now touch us, linking our moment to theirs in a single unbroken thread. Somewhere beyond even Webb's reach, there are stars whose light has not yet reached us. Their glow is still on its way, a message traveling through expanding space, a letter from the past that will take billions of years to arrive. The universe continues to write to us in light, and we, through our curiosity and wonder, continue to read. The cosmic dawn was not the end of darkness. It was its transformation. Shadow became contrast. Contrast became pattern. Pattern became beauty. And beauty, the quiet recognition of order within infinity, became the first form of awareness. Even now, as you listen, that awareness endures. Every atom in your body remembers that dawn. Every photon around you once belonged to it. And as you breathe in slowly, gently, you are participating in the same rhythm, the exhale of darkness into light. From the first dawn of light, the universe learned to weave itself threads of brightness, stretching through the shadow knots of matter, forming stars, galaxies, and the soft structures of time. But for all its luminous detail, something remains hidden. Even as we gaze back to the cosmic dawn, we find that most of what exists cannot be seen at all. The stars, the galaxies, the glowing webs of gas, they are only the visible portion of a much larger design. This unseen substance shapes everything. It sculpts the paths of galaxies, guides the motion of stars, and defines the geometry of the universe. It neither emits nor absorbs light. It is known only by its gravity, by the way it bends what we can see. We call it dark matter. And within that mystery lies another, the possibility of primordial black holes. Ancient objects born not from dying stars, but from the earliest moments after the Big Bang. If they exist, they may hold the key to understanding both the visible and invisible universe, a bridge between what glows and what does not. To imagine these black holes, we must return again to the universe's beginning, to a time when everything was compressed beyond imagination. Space itself was unstable, rippling with fluctuations in density. Tiny variations smaller than atoms were amplified as the cosmos expanded. Some regions became slightly denser than others, and in a few rare places, the density grew so extreme that gravity overcame expansion. Matter collapsed inward, forming black holes just seconds after time began. These primordial black holes could be as small as mountains or as large as suns. They would not shine, but their gravity would endure. Some might have evaporated quickly, releasing brief flashes of radiation quantum whispers, known as Hawking radiation. Others might have survived scattered invisibly through the cosmos, still drifting among galaxies today. It is possible that they make up a portion, perhaps even the majority of dark matter. If so, then the universe's hidden mass is not an abstract field or exotic particle, but a population of ancient black holes, remnants from the first heartbeat of existence. The thought is both haunting and elegant, that darkness itself may be composed of collapsed light frozen from a time before stars existed. That black holes, which we usually associate with endings, may in truth be among the oldest beginnings. Webb, with its vision tuned to the earliest light, cannot see these black holes directly, but it may sense their influence. If primordial black holes were common, they would have shaped the early cosmos, creating gravitational wells where gas gathered and stars first formed. They may have served as seeds for the earliest galaxies, drawing matter together long before any visible structures appeared. And so the story of light and darkness grows more intertwined. The same forces that gave rise to the first stars may have been guided by invisible anchors, silent points of gravity older than any starlight. To explore this idea, scientists turn to clues written into the cosmic background radiation. Tiny irregularities in that ancient light show where matter was distributed unevenly in the early universe. If primordial black holes had been abundant, their presence would have left subtle marks, faint distortions in that first afterglow. Some patterns hint that such traces might exist. Others suggest they are rare, perhaps existing only in special regions. The data whispers but does not shout. The mystery deepens. Dark matter, though invisible, reveals itself through motion. Galaxies spin faster than visible matter allows. Clusters of galaxies bend light more strongly than their stars alone could account for. Something unseen holds them together, something 5 times more abundant than everything that shines. Yet no particle, no field, no equation has yet fully described it. Perhaps it is made of WIMPs, weakly interacting massive particles that drift silently through space. Perhaps it is composed of actions, particles so light and subtle that billions pass through you each second without a trace. Or perhaps it is made of black holes, the oldest relics of creation, born from fluctuations in the first instant of time. If so, then dark matter would not just be the skeleton of the universe. It would be the memory of its birth. Primordial black holes challenge our imagination. They would have no luminous halos, no glowing disks, no radiation to betray their presence. They would pass through galaxies unnoticed, detectable only by their gravity. Sometimes one might pass in front of a distant star, bending its light just enough to create a flicker, an event astronomers call microlensing. These flickers, rare and brief, are among the few ways we can glimpse the presence of such hidden masses. And so telescopes watch the sky patiently searching for these momentary twinkles. Each one, if found, could be a message from the universe's first seconds, a signal from a time when space and energy were still learning how to separate. If primordial black holes exist in large numbers, they could explain the mass that dark matter contributes to the cosmos. They could be the silent architects behind every galaxy, every cluster, every shape we see. And their existence would bridge two of cosmology's greatest mysteries, the origin of black holes and the nature of dark matter. But the idea is more than theoretical. It is almost poetic. Because if black holes truly predate stars, then light and shadow began together, not as opposites, but as twins. The first light of the universe rose from the same conditions that created the first darkness. Every galaxy, every sun, every being that will ever exist was shaped by both. In this way, the universe mirrors the balance that defines all things. Light reveals, darkness sustains. The seen depends upon the unseen. Energy requires space to expand into. Even consciousness, fragile and bright, depends on the quiet backdrop of the mind. Perhaps dark matter is not a missing piece, but the foundation itself, the silence that allows the music of galaxies to be heard. And perhaps primordial black holes are the deepest notes of that symphony vibrating through time, unheard but essential. They do not interrupt creation, they anchor it. Their gravity holds galaxies together, their silence gives structure to light. When you look at the night sky, you are not just seeing stars, you are seeing what their darkness permits. Between every point of brightness lies the invisible field that keeps them bound, the gravitational memory of creation's earliest moments. Imagine for a moment a universe made almost entirely of invisible mass, a cosmic ocean of gravity where islands of light float like bioluminescent creatures. That is our universe. We see the islands, but the ocean itself remains unseen. Dark matter and perhaps primordial black holes are that ocean. They are the medium in which all things move the silent companion to every photon. Even the galaxies that Webb observes, those shimmering spirals and ellipses, are only the brightest crests upon an invisible tide. They are patterns on the surface of something deeper shaped by dark matter's slow currents, guided by gravity's unseen hand. And so, the universe is never entirely visible. No matter how far we look, no matter how sensitive our instruments become, part of it will always remain hidden, not as a failure of understanding, but as an intrinsic quality of existence. There is always more than light can show. Perhaps that is why these mysteries feel so human. We too live surrounded by the unseen, by memory, intuition, emotion, silence. We too are shaped by what cannot be measured. Our visible actions are the luminous surface of an inner gravity, a pull that guides us even when we do not see its source. In that way, dark matter and primordial black holes remind us of something profound, that mystery is not emptiness, but potential. That what cannot be seen still carries meaning. That the invisible is as real as necessary as the light itself. One day, perhaps our instruments will find clearer evidence. Gravitational waves from merging primordial black holes. Faint lensing events scattered through the sky. Tiny ripples in the cosmic background. Radiation that betray their hidden mass. When that happens, we will not just be learning about the universe. We will be completing a story that began at the beginning. The story of how light and darkness were born together. Until then, we listen. We build telescopes, we measure light, we map the unseen. Each observation is an act of faith, a belief that the cosmos will share one more secret if we wait long enough, if we watch with quiet patience. And as we wait, we can take comfort in this. Even now, the invisible holds us. Dark matter surrounds our galaxy, enfolds our world, passes through our bodies every moment. It is not somewhere far away. It is here, woven into the very fabric of reality. The same invisible mass that shaped the first galaxies also shapes the space between your heartbeats. The same gravity that guided primordial black holes guides the motion of every atom around you. The boundary between cosmic and human is not as distant as it seems. In every scale from the vast to the intimate, the same principle endures the unseen, sustains the seen. The silent carries the sound. The dark gives meaning to the light. The invisible holds us. The unseen shapes us. From primordial black holes to the shimmer of galaxies, the same forces that built the universe still breathe quietly through every moment of our lives. And as we drift, suspended between the known and the unknown, a simple truth unfolds that we are not outside the cosmos, but within it. We are part of its memory, part of its movement, part of its endless unfolding. The story that began with the Big Bang has never truly paused. It continues through every heartbeat, every breath, every flicker of thought. The universe expands, and we expand with it, not in distance, but in awareness. Even now, the light that left the first stars still travels through us. It passes across our eyes as starlight flows through our atoms, as radiation echoes within our molecules as warmth. You are in every measurable way an extension of that first dawn. The carbon in your lungs, the iron in your blood, the calcium in your bones, all were forged in stars that lived and died billions of years ago. The hydrogen that fills your cells was born in the first few minutes after the Big Bang, when the universe was pure energy cooling into matter. You are older than the earth, older even than the sun. You are made of time itself, condensed into awareness. And yet, for all the science that explains our origins, there remains a deeper rhythm, a quiet, meditative understanding that we belong. The same physics that binds galaxies together binds your molecules in place. The same gravity that guides the motion of stars guides the arc of your breath. The same expansion that carries galaxies apart allows your thoughts to wander endlessly outward. The cosmos does not end at the edge of the sky. It continues inwards through you, through every cell and particle. When you think, when you feel, when you sleep, you are participating in the same unfolding that began 13.8 billion years ago. You are the universe experiencing itself in human form, momentarily aware of its own beauty. The atoms that make you are not static. They move, they change, they exchange with the world around you. The air you breathe was exhaled by trees, by oceans, by countless beings who lived before you. Every breath is a communion, a transfer of stardust between forms. You inhale what the cosmos has exhaled. You exhale what the cosmos will one day inhale again. Even silence is part of that exchange. When you close your eyes, when your mind quiets, you join the rhythm of the universe, the long, slow breathing of existence. It is in that silence that the connection becomes clear that you are not small, not separate, not temporary, but continuous with everything that ever was. Astronomy teaches us this without asking for belief. It offers the truth of perspective that scale does not diminish meaning. We are small, yes, but we are also vast in another way. We are made of the same light that travels between galaxies, the same energy that fuels the stars, the same gravity that shapes the dark. The cosmos is not something we look at. It is something we are. In the soft darkness of night, when the air is still and the stars begin to appear, you can almost feel it, that gentle kinship with everything above you. Each star is a fragment of your own origin story, a reminder that distance does not mean separation. Light travels for billions of years, yet it reaches you now unbroken, as though it never left its source. Connection endures, always. And in that connection, something ancient stirs the quiet awareness that we are temporary expressions of something eternal. Our lives may be brief compared to stars, yet the matter of our being is timeless. When a star dies, its elements disperse into the galaxy, and from those ashes, new stars, planets, and living forms emerge. We are part of that same cycle. We are starlight made conscious. The astronomer Carl Sagan once said, "We are a way for the cosmos to know itself." Each discovery, each moment of awe, each act of wondering fulfills that purpose. When you look at the night sky and feel that mixture of beauty and mystery that is the universe looking back at itself, recognizing its own reflection, the distance between observer and observed collapses into one. It's easy in the quiet of thought to imagine the universe as something external, distant galaxies expanding space in visible matter. But if you follow that thought inward, you find the same processes mirrored within. Your heartbeat is a pulse like the rhythm of stars forming and collapsing. Your mind is a galaxy of neurons sending light-like signals through their own dark expanse. You are a small-scale echo of the whole, a microcosm that reflects the macrocosm. The cosmic connection is not philosophical abstraction. It is physical truth. When you lift your hand, you lift atoms that were once part of ancient suns. When you see starlight, those photons enter your eyes and become part of your perception. When you breathe, you participate in an unbroken chain of exchange that stretches across time. To live is to move within that field of relationships, to be both cause and consequence of cosmic history. Every heartbeat is part of an unending wave. Every thought ripples through the same physical laws that govern galaxies. The more we learn about the universe, the more intimate it becomes. The vastness does not push us away, it draws us closer. For in learning how stars are born and die, we learn how we ourselves were born and will transform. In tracing the origins of light, we trace the origins of our own awareness. In studying the forces that hold galaxies together, we uncover the quiet balance that holds our own lives in motion. The James Webb Space Telescope, suspended in its perfect balance point 1,000,000 miles from home, watches these truths unfold. Its golden mirrors reflect not just ancient light, but human longing, the same curiosity that built fires in caves that named constellations that sent instruments into the dark. Webb is an extension of our senses, a golden eye that allows us to remember. And what it sees, galaxies forming stars, igniting light stretching through time, it sends back to us as a mirror of our own story. We built it to look outward, but everything it shows us points inward. When Webb captures the faint light of a galaxy from 13 billion years ago, it is showing us our own origin. It is reminding us that we are not separate from that ancient glow. We are made of it. Every discovery brings us home again, not to Earth, but to belonging itself. The universe does not exist to make sense. It exists to continue. And we are part of that continuation. Our purpose, if we must call it that, is to witness, to see, to feel, to understand, to add consciousness to the fabric of existence. We are the cosmos made aware of its own motion, the brief shimmer of recognition within an infinite unfolding. Even the mysteries that remain dark matter. Dark energy, primordial black holes are not signs of ignorance, but of wonder. They remind us that the unknown is not a void, but an invitation. That mystery is the natural language of the universe, and curiosity its translation. Each unanswered question is a doorway leading us further into understanding, further into humility. And yet, even if we never uncover every secret, we already know enough to rest in awe. We know that we come from the same event that created the stars. We know that every atom within us has traveled through countless forms. We know that light and darkness are not separate, but partners in the same eternal dance. That knowledge is not cold or distant. It is deeply comforting. It tells us that nothing is wasted. Nothing is truly lost. Even after death, the matter that composed us will return to the cosmos, to begin again in new shapes, new rhythms, new lives. The universe is ancient, but it is also young, renewing itself with every heartbeat, every spark, every sunrise. Even now, new stars are forming in distant nebulae. New galaxies are taking shape in the far reaches of space. And somewhere, perhaps new minds are awakening to wonder, just as we do, gazing into their own skies and asking the same timeless question: what lies beyond the edge of space? That question is not meant to be answered fully. It is meant to be lived. Each breath, each act of perception, each quiet night beneath the stars is an answer written in the language of experience. We do not solve the universe, we participate in it. We are the edge looking back at itself. As you lie here, perhaps half awake, perhaps already drifting, imagine the slow turning of the galaxy, the Milky Way spinning gracefully, its arms unfolding in silence. Somewhere within that spiral is you, small but essential part of the great motion. The starlight that travels for billions of years arrives softly at your window, and for a brief moment it rests upon you, the same light that touched the first dawn. The universe continues vast and calm. It expands with quiet patience, scattering its light, gathering its shadows. And within it, You rest a being of stardust and thought, a consciousness shaped by gravity and time. You've traveled far tonight through beginnings and endings, through light and darkness, through time itself. And now, at the edge of awareness, you may let go. Let your mind drift as galaxies do. Let your thoughts dissolve like starlight in the dark. The universe will continue its rhythm steady and eternal. The same atoms that shine in stars breathe quietly within you. The same gravity that binds galaxies holds you here gently in this moment. You are made of everything that ever was, and everything that will ever be. The universe hums softly, endless and serene. And you, luminous, temporary infinite, can rest now.